This practice is explain how we can find the distance between the Earth and the Sun. So this means how can we determine the astronomical unit 1 AU? This is a question. You might think that we can use a parallax method. We have learned parallax method to determine the distance between the Earth and the Sun. You are right, partially, but you also recognize that it is difficult to measure the distance accurately. It is difficult to have a long base distance on the Earth compared with the distance to the Sun. So if you want to measure this distance to the Sun on the Earth, you and your friend. So compared to this base, this is the base. If you look at the sun is located above your head, and this is you. Also your friend expressed in the same ways. This is nearly the 90 degrees. So we have to use longer baselines. This base is really important to determine this distance. So in the last practice, I have already explained how to determine the distance to the moons. So this is the Earth and the moon. Moon is much closer to the Earth compared with the distance to the Sun. So in this case, you and your friend can stand to measure the distance to the moon. So for example, this moon. And A and theta, as I explained, the submoons. Distance to the moon can be expressed A tangent theta. Okay, so this equation is very useful, parallax method, to determine the distance to the moons. But in the case of the suns, this base might be too short. Even if you move the really long distance on the Earth, still the distance between you and your friend is much shorter than the distance to the sun. So we cannot use this method. How can we apply the parallax method to determine the distance to the suns? But as I already explained, we have already know the distance between the Earth and the moons. The moons we know. Maybe this length is much longer than the distance we can have on the Earth, on the surface of the Earth. Maybe it's better to use the submoons as a base. So now the moon is here and the Earth is here. Maybe we can use this length as a base. Base is the submoon. Then we should consider the location of the suns. If the sun happened to be located in these directions, this is sun. This is the configuration of the sun and the moon and the Earth. Then what kind of the moons we could observe in these situations? Actually, sun emitted light in all the directions. But in the case of the moons, half of the region is emitted, is coming and shining, it becomes bright. But the other half becomes black. So in this situation, if you observe the moons in these configurations, we could observe the half moons. So when you observe the half moons, three objects, sun, moon, and the earth in this configuration. Then we could, as I explained, we could use a base of the D submoons as a base. Then we'd like to find the distance, earth and the suns. This is D. And this is theta. So we could observe the direction to the moons and the direction to the suns. And we could find that this theta. Theta is the angles. Then we can use a trigonometry to find the D. Because cosine theta. So this is a right angle. Cosine theta is D submoons over D. So you can find the D. D is distance to the sun. Is obtained D submoons over cosine theta. So in this case, we still use a trigonometric function to determine the distance from the Earth to the Sun. This is equal to 1a. This is how we find one astronomical unit, the distance between the Earth and the Sun. Okay, this is the answer to this practice.